Hello and welcome. Today we'll be solving the question maximum depth of binary tree. I think this is a really good problem to solve and understand to better increase your expertise on the data structures trees. So let's just get started. The question reads, given the root of a binary tree, return its maximum depth. Now the maximum depth is the number of nodes along the longest path from the root node all the way down to the furthest leaf node. Okay, so with the example that we have here in example 1, just looking at it visually, it's very easy to say that, okay, the maximum path will start from 3, go down to 20, and it can either go down to 15 or to 7. The point is the maximum depth is going to be 3 because along any of these paths, we encounter 3 unique nodes. So that is why the response will be 3. Now, I'd argue a good way to understand this problem is to sort of think about it going from the bottom to the top. Now, in actually solving it and implementing it, as you've seen the code later, we'll be solving it obviously from the top down because we are given the root node. But for the sake of understanding, let's think about it from the bottom up. Now, the way we want to approach this problem is whenever we see a node, we are just going to ask it one question. And depending on the response it gives to us, we are going to do one of two things. So let's start with the node represented by the value 15. So we get to the node 15 and we are going to say, okay, are you a node? It says, yes, I'm a valid node. The moment it says that, we are going to assign it the value 1. And then we are going to add the maximum of running the same function on its left child and right child. Now, obviously, its children, the children for 15 are null pointers, so that is going to return 0. So we know as far as 15 is concerned, the result is going to be 1. We are going to move to the right, do the same thing for 7. Say, okay, are you a natural node? It says, yes, I'm a natural node. I even have the value 7. So we are going to return 1 plus the maximum of running this same function on these 2 children, which clearly are non-existent. So this returns 0. So in terms of the node with value 7, we return the number 1 as well. Let's make this fun. Let's go all the way to the top. Not all the way to the top, just the number right above it. Now we are at 20. We are going to ask you the same question. Are you an actual node? It says, yes, I'm an actual node. I even have the value 20. So it's okay. By virtue of that, you get the privilege of having to return the value 1 plus the max of running these same functions on your left child and on your right child as well. Now, obviously, the max between 1 and 1 is going to be 1. So in terms of 20, we are going to return the number 2. Now we'll go to its sibling, which is 9. I only say sibling because they are children of the node 3. Ask you the same question. Are you a node? It says, yes, I'm a node. It says right there and there, you're already returning the value 1. But we are going to add the maximum of running this same function on your children. It says, no, I don't have any children, so that's 0. And that means in reference to the node of value 9, we'll return the number 1. Okay, so now we are actually going all the way to the top, which is the root in this case, the number 3. We're going to ask you the same question. Are you a node? It says, yes, I'm a node with the value 3. So, okay, because of that, we are going to return 1 plus the maximum of running this same function on your left child 9 and your right child 20. Now, 9, we are returning 1, and 20, we are returning 2. So it's going to be the max, right? So that will be 1 plus 2, which is 3. And you'd realize this correlates with the expected value we want to have. Okay, so then what does the code look like for this? or how are we going to go about implementing this? Now, this is a question that's one of the best ways to solve it is depth first search, because like you realize from my example, really all we are doing is whenever we get to a node, by virtue of some conditions we have set, which in this case is figuring out the maximum of running the function is 2 children. We just go down that way. We just keep going down. So it's going to be a depth first search algorithm. Now, I know looked at this question from bottom up, obviously for the sake of clarification, but in implementing the code, we are going to actually go top down because we are given the root node, and that is really all where we can start from. But I do this bottom up so that we have a good understanding of what the recursive course is going to look like, because thinking about recursion can be difficult, but then looking at it from bottom up, we have a good idea of what each of these nodes are supposed to return based on the rules we have put in place, right? So now the way we are going to go about this is obviously we are given the root node. So we are going to ask it the same question we've been asking when we started from bottom up. We say, okay, are you an actual node? And if you're an actual node, we are going to return 1 plus the max between your 2 children. In this case, that would be 1 and 2. So obviously, this is going to return 1 plus 2. And that would give us 3. So obviously the way this works is when we start from 3, as you would see in the code, it's really when we confirm that the node is a valid node, we give it the number 1 and we add it to the maximum between these two. From this example, you see that we can already stop right at the next step and already declare what our return value is going to be, only because we have worked at it from bottom up, so we have a good understanding of what all these nodes look like. So let's look at the code. There's one of those questions where looking at the code actually brings so much more clarity than even looking at a picture of it. Now, in the question, you see that really all we are doing is for every root node we see, if it is not a root, or it is a null pointer, or it is none, we are just going to return 0. But if not, and we confirm that it is an actual root, we will return 1 plus the max between this left child running the same function on it and its right child, and we just do that recursively. Now, I know the code on line 13 can be daunting if you don't have a good grasp on recursion, hence why I did a bottom-up approach. And I hope this gives you some clarity in terms of like approaching the question. Like any other question, you can solve this in a number of ways, but I think this is one of the easiest way to navigate it, even represented in the number of lines for the code. Thank you so much for taking time to watch this, and I hope it was helpful for you. Please feel free to leave questions, comments, suggestions that can make this learning experience better for you. Thank you, and I hope you're having a good day.